Hello and welcome to this Python tutorial. Alright, so today we will be making the update function, which will update everything there is to update as soon as the AI reaches a new state. So when it reaches a new state, we need to update the action. The last action becomes the new action that was just played, but also the last state that becomes the new state, and finally the last reward that becomes the new reward we get when we play the action. So that's the logical path that happens right after selecting an action. We need to update all the elements of the transitions. And of course, we will get a new transition, so we will have to append this new transition to the memory. And finally, we will also update our reward window, to keep an eye on the evolution of how the training is going, and how the exploration is going. But what's most important for you to understand is that now we can finally make a connection between the AI that we're implementing right now to our map. Because if we go back to our map, remember there is this big update function into the game class. So that's where we're actually making the game with the car and defining how the car should be punished when it's making a mistake. But in this game class, we notice this update function. And in this update function, we notice this line, action equals brain.update last reward, last signal. And actually, this is exactly what we're about to make. We are about to make this update function that will take the last reward and the last signal to get the next action to play. So not only will we update all the different elements of the transition, but mostly we will be playing the action that we should play when getting the last reward and the last signal. And so of course in this update function, we will use the select action function that we just implemented before. We will integrate this select action function in the future update function that we're about to make to select the right action to play besides making all the updates. So that's really important to make this connection with the map right now. What we're about to make is eventually the connection between our AI and the game that we make in this class. And so what we can do now is directly take this update last reward, last signal, because that's exactly the function that we will be making with these two arguments here. And just as a quick reminder, brain is our AI object. That is, it's the object of the DQN class. So what we're going to do now is we're going to copy this, update last reward, last signal, and that's going to be our next function we're making, and therefore I'm pasting that here. Then just to be careful, I would just like to give some different names than the names we have here. We have last reward here, and I don't want to confuse this last reward with this one. That can be dangerous. So I'm going to replace last reward here by reward. And by the way, same for last signal. Let's just put signal or even new signal to specify that, we want to make the update when reaching a new state and therefore getting a new signal. But then of course, this reward here is going to be the last reward that we get here. When going onto some sand, or worse, getting too close to one edge of the map. That's where we define the last reward. This last reward is going to be the input of the update function, so that's why we have last reward here. But right here, I'm just giving another name for the argument, reward, to not confuse it with last reward here. Alright, so this is the update function, and now let's go inside it and let's do these two things, that is update all the elements of our transition and of course select the action. Okay, so what do we need to update first? Well, as you understood, we want to make the updates when reaching a new state. So the first thing we'll be updating is obviously this new state. That is the new state we're reaching. So I'm going to call this new state, and then equal. And so how can we get this new state? Well, of course, that depends on the signal, the new signal that the sensors just detected. And as a reminder, the state is the signal itself, composed of the three signals of the sensors, signal 1, signal 2, and signal 3, plus orientation and minus orientation. That's our state, so be sure to understand that the signal is the state, but right now it is a simple list of 5 elements. And since this is going to be the input of the neural network, remember we have to convert it into a torch tensor. So that's exactly what we're going to do right now. We are going to take our torch library and then take the tensor class, there we go, which will convert our new signal into a torch tensor. Then it's better to make sure that all the elements of the torch tensor are floats. So I'm going to make a type conversion to convert them into float, like this. And then finally, try to get the reflex of what we need to do next. It's of course to create that fake dimension, to add the dimension corresponding to the batch. And we do this of course with the unsqueeze function, to which we have to input the index of this fake dimension we want to have for the batch, which is 0. Alright, and now we have our new state, composed of the 3 signals of the 3 sensors, plus orientation minus orientation. And of course that will depend on the new signal we're getting with this update function right at this line. Last signal, we get the 3 signals plus orientation minus orientation. And as a reminder, the 3 signals are the density of sand detected around the sensors. Alright, so we just got our new state, so that means we reached the new state, and now we have to make the next update. So according to you, what do we need to update now? What would be the logical thing to update right now after reaching this new state? Well, what we need to update now is the memory. Why is that? It's because at each time t, a transition is composed of the current state, st, the next state, st plus 1, the reward, rt, and the action, at. And right now, we already have st, we already have rt, and we already have at. And we just got the last element of the transition, st plus 1. So by getting this new state, st plus 1, we are getting one brand new transition of the memory. And therefore we have to append this brand new transition to the memory because that's simply our next transition. So that's why we have to update the memory right now. And therefore, what I'm going to do is take my memory object created from the replay memory class. And therefore, I'm going to take self.memory to refer to the object. But since I'm using self, I have to include the self in the update function. So now you can really see what this self is for. It's whenever you use one variable that you created and initialized in the init function. So self.memory, and now we need to update it. And according to you, how are we going to update that? Well, the good news is that we already made a function to do that. It's the push function which appends an event or a transition to the memory. So that's exactly what we're going to use now. We're going to use the push function to append our new transition that we just made to the memory. And therefore, here I'm taking not an equal because we're going to use a method, and therefore we can directly use dot push. And first, I'm going to add the transition, this new transition that we just got, and that is first the last state. So self.lastState. So that's st. That's exactly this one. It already exists. Then the next element of this transition is, of course, the new state that we just reached. And therefore, since it is not a variable of the object that we created and initialized in this init function, we don't put a self here. We directly put the new state. Then the next element of the transition is the action. And same, we already have the last action, which is this self.lastAction here. So of course it is equal to 0, but then of course it will be updated with the select action function. But that's this one. So then it is self.lastAction. But now be careful. The elements that we're including in this transition should all be torch tensors. As you can see, that's the case for the last state. It's a torch tensor. The new state is also a torch tensor. And so this must be the same for the action and then the reward, of course. But now you're going to think, how can it be a torch tensor considering that it's simply a number? You know, the action is either 0, 1, or 2. But in fact, that's not a problem. We can still convert this 0, 1, or 2 variable into a torch tensor. This will just be what we call a long tensor. The long is a type, and that's the tensor that will contain an integer, because the last action is an integer. It is 0, 1, or 2. So what we're going to take now is our library torch. Then we're going to take the long, here it is, the long tensor class that will create an object, which will be the long tensor itself. And by taking the self last action function as input, it will create this long tensor object but it will still contain 0, 1, or 2 into a long tensor object. And that is just to be consistent with the transition that should only contain tensors, because we're working with PyTorch and we're working with a neural network, so we have to work with tensors. So there we go, torch, long tensor, and one last conversion to make. We must be sure that what's inside this long tensor is an integer, and to make sure of it, even if we already know that the last action is 0, 1, or 2, to make sure of it, we're going to make this int type conversion again. We convert our self last action into an integer. There we go, and then we must just put the integer self last action into brackets right here, so that now we get a long tensor of one element, which will be this last action 0, 1, or 2 itself. So the key point is, that's just how you convert a simple number 0, 1, or 2 into a tensor with Torch. Alright, and then finally, the last element of the transition, and that's of course the last reward we got. So that's exactly the last reward variable we created in the init function that was initialized to 0, but then of course is updated right here in this code, either when we go onto some send, which is a negative reward, or if we get further away from the goal, that's again a negative reward. If we get closer to the goal, that's a positive reward. And the worst punishment, if we get too close to one edge of the map, well, that's a terrible negative reward, -1, and that's all. So let's add this last element of the transition, self.reward. So I'm copying this, pasting that here, and now we have to make another conversion, which will be of course exactly the same as this one, only since the reward is not an integer but a float number, we will simply make a torch.tensor conversion, but without the int. We will keep the brackets here, because first we have to put the number into a list, and then this list will go as input in the torch tensor class, but we don't have to make that int conversion because last reward is a float number. So what we're going to do is simply add here torch.tensor, then parenthesis, brackets, and we're going to close the brackets here, and we close the parenthesis. There we go. So to summarize, with the new state that we just reached and the reward, we observe a new event of transition that we add to the memory. And this transition contains the last state, st, the new state, st+1, the last action played, at, and the last reward, rt. Alright, and now we are good with our memory update. So let's have a quick break and we'll take care of the next update in the next tutorial. Until then, enjoy AI.